Hello everyone, welcome to Civil Mania. So in today's lecture I will be explaining from the beginning to the end, that is like how to do the designing analysis of a small school building, as well as how to do the drawings, so that is structural drawings from the basic level to the advanced level. So as you can see here, this is a small school building. This is the architecture of the small school building. So after you in our initial stage you will get the drawing of the architectural building, and from this architectural building we have to properly develop the full structural drawing. That is in the structural drawings, the first step will be to draw the column center line. This is the column center line. Okay, then the second part of the drawing will be the footing layout and detail. Here we will be providing the footings, such as how to draw the footing drawings. Then in the third it will be the column details. As you can see here, this one is the column details. Then in the next will be plinth beam layout and details. Then in the next step we will be drawing first floor beam layout and details, if first floor is present, and if there is as in this building, as you can see here, this is the first floor, and above the first floor the roof is present. So after the first floor layout and details, there will be simple roof beam layout and details. After that wherever the roof beam is present, there will be only the slab. This is the slab of the first floor drawing. Okay, and this is the drawing of the staircase, and this one is the drawing of the truss which is present over this portion of this portion in the roof. So in the initial step, in the first initial step, as you can see here, the compulsory thing is we have to draw the grid lines. As you can see here, the grid lines are being present. So this one is one grid line. From the one column to the another column, there will be another grid line that is marked as B, then C, D, E, F, G, H. In the similar manner, we have to serially draw the grid lines in both the vertical direction as well as in the horizontal direction. So this is the first step you have to do. After drawing the grid lines, what you have to do is, now simply you have to go to the Etabs. In the Etabs, you have to first select as new model. After selecting the new model, we have to select as use settings from a model file. Okay, use settings from a model file, or else you have to simply use built-in settings. So let me first in this example I will show you step by step, that is how to use all the settings. So use built-in settings. As here you have to use metric, then our country India, then Indian code, then steel code IS 800, then next one is the concrete code, that is IS 456. okay, then in the next step you have to select as the grid only. Okay, after selecting grid only, as you can see here, this grid lines will be present present by default. Then what you have to do is, you have to simply go to these grid lines and you have to click right click over this area. Then you have to click on the add or modify grids. After clicking here, you have to go to this modify or show grid system. After clicking it here, what you have to do is, you have to simply go back to the previous architecture drawings, and before going there, you have to click on in the display grid data as spacing. Instead of display grid data as ordinates, you have to click on display grid data as spacing. Now again go back to the architectural drawing. As you can see here, first one is 4800, then 3350, 4800, 3350. This one will be 4.8, as hours is in meter, 4.8. The next one is 3.35, the next one is 3.35, the next one is 2.8. Then go on adding. After 2.8, the next one is 6.15. So let me complete these steps. So this is how I have completed, but remember that this one is 4.80. so as you can see here, this one is 4.80. in the last one keep it as 0. Similarly go on adding for the vertical lines. So let me go here. Always remember that the grid line starts always from the left hand side for the horizontal one, and for the vertical ones it will start from the bottom. So 7.850. so first one is 7.850, the next one is 2.550, the next one is 4.8, the next one is 4.8. so this is how I have here. Also the same thing here I have added all, as last one is 6.15. Then I will click OK, and after that again click OK. So these are the grid lines which I have done it here. So after drawing the grid lines, my next step will be you have to draw the beams and columns as it's shown in the this architecture drawing. So these are the columns present here, and these wall lines wherever the walls are present, here will be providing the beams. So let me go to the Etabs drawing. Then here let me first go to the define. In the define section, go to materials first. So add new materials, concrete India M25, click OK. First M25 I have added. Then next add rebar, that is one is FE 500 and second one is FE 415. Remember you have to add FE 500 in place of FE 550, because though in market FE 550 is available, but you have to select FE 500 because it is present, because we are taking FE 500 as per IS 456, because none of the calculations is available in IS 456 for FE 550. So you will be taking as HOSD 500 and HOSD 415. This one is the main bar and this one is the secondary bar, and this is the grade of concrete. Then click OK. After that again go to define, then section properties, then frame sections, then delete all these are which are available here, because these are of no use, because these are always comes by default. Only one cannot be deleted, the last one will not be deleted. See, at least one frame section should be present. So keep this one section. Now click on add new property. After clicking on add new property, concrete rectangular, select this one. After that, first let me assume that my column size will be 350 by 350, and this is the basic size which I have selected, because as per IS code the minimum size of the column is 300, but another one condition is there which is as per IS 13920, that is ductile detailing code, because we are especially doing the design for the seismic zone 5. As I belongs to Assam, so I am doing the designing for seismic zone 5. so I have selected both the criteria, that is one criteria is the minimum criteria for the concrete column size, and the second criteria is 20 times of the and second criteria will be the 20 times of the size of the reinforcement, that is the size of the bars which we will be going to use. So suppose we are going to use the 16 mm bar and 12 mm bars, then that the larger one which will be present, that is the 16 mm bars which will be present, it's 20 times. So 20 into 16 will come out as 320. So the minimum size will be 320. And suppose if we will be going to use 20 mm bars and 16 mm bars, then 20 times of 20, that will come as 400. So the minimum size will now be 400. So I am supposing the minimum size is 350 by 350 for the concrete column, and here I will write it down as 350. Here the width is also 350. Then I have to select the modifiers. For the concrete column, the modifiers will be moment of inertia. We'll keep this modifiers as 0.7 and 0.7 specially for the columns, and this one is the longitudinal bars, main bars, and this one is the secondary. I will keep this as 415. Rectangular corner bars will be more, and other bars will keep it as smaller. Confinement bar, these are actually the bars of the lateral ties, which will keep it as 8. Okay, so this here it's for the columns. So okay, so this is how, see, these are these I have provided bigger sizes in comparison to the other bars. So click it as okay. So this one is for the column. Suppose let me use another for the beams. So add new property. So let me select for a beam, that is for beam I will keep it as 250 by 500 size of beam, or keep it as 250 by 450 m25. okay, so depth will be 450 and the thickness width will be 250. Here I will keep the torsion as 0.001, and moment of inertia will be for the beams will be 0.35. remember this, that this moment of inertia for beams and the columns which I have taken is as per IS code. So okay, now go to longitudinal bar 500. Now do for the designing of the beams. So for the beams, the top bars and the bottom bars, but remember that this one is not the clear cover, this is the effective cover. So what I will do is I will show you the calculation part, that how I have taken the effective cover. Calculator. Suppose the clear cover of the beam is 25 plus, then after taking 25 mm or 30 mm, then what will be present is then the diameter of the stirrups will be present, that is 8 mm. After that the reinforcement will be present. The reinforcements, that is the longitudinal bars, will be present. So longitudinal bars, suppose we are going to use 16 mm longitudinal bars, so then 8 mm in this side and 8 mm on the another side, so we have to sum up as 16. So this one is the 40, it's coming as 49, so we have to use 49 as the effective cover for top and bottom. Click OK. So this one is for the beams and this one is similarly. If we require another size, let me go to this one again and select as FE M25. Again let me go to the beams and simply click in add a copy of property. Here select as beam 250 by 500. So simply make this one is 500, rest everything is okay because I have already created for the 450 beam. See, so in this manner we can create, also we can create column. Suppose add a copy of property, then column 350 by 450, 450 will keep it as depth, rest everything is okay. Now click on OK. After that, what we have to do is we have to click in this one, click in this portion. So this one is the button for the quick draw columns. After clicking it here, quick draw columns, we will be going to select as what will be the size of the columns. Suppose I will be selecting as 350 by 350. Now let me again go to the architectural drawing and place wherever the beams are present, here, 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 here. So place here beams wherever it is present. Here beams are present. Then similarly in this manner the beams are present. Then again the beams are present. Here the beams are present, and here beams are present. Then the beams are present here. Now next one is in this manner. Let me complete wherever the beams wherever the columns are present. So this is how we have made all the columns. Now let me go to this quick draw. This one is the quick draw columns, and this one is the button for the quick draw beams. And after that we'll select all the beams, that is 250 by 450 size. Then let me go on clicking simply 250 by 500, or do one thing, simply go on dragging. This is how we have created. Now save the project by going to this one and save as. Save as, simply make one new folder and save as school. So wherever it's required or wherever it's not required, we have to simply click the escape button, and you have to check wherever the beams are required and wherever the beams are not required as per the architectural drawing. So here the beams are not available, so in this portion the beams are not available, so simply delete it. And as you can see here even after this staircase the beams are present up to here. After that the beams are not required, so these here beams are not present, here also the beams are not present. So these are the portions where beams are not present. Then again go to this portion, and these two beams are also not present, so here the beams are present. Then after that what you have to do is you have to again check it as here. Then in this portion the beams are not present, so delete this one also. Then let the beam be present here. Then this one, so here the not necessary beams. So after that what we have to do is here the beams are present but here the beams are not necessary, so delete these beams wherever it's not necessary. So along with that I hope this one is also not necessary, so delete this beam as well. Then I hope this beam is necessary. See, this beam is necessary up to this portion. It's okay present here, but this beam is not necessary, so delete this beam. Simply click and press the delete button. Now let me check once more. See, this span is much higher, much more than. Let me go to the edit menu, and after going to the, not instead of edit menu, go to the view menu, then here measure is present, or simply control M, click it from here to here, measure it. How much? It's showing as 9.9 meter, so it's much higher. So instead of placing instead of this beam, we have to place another beam. So here I have already placed it. So let me place the column here also. Let me place the columns here, but in between I cannot place the column because it's library. So here I cannot place the columns. So then any other alternate solution will be, there will be no any kind of alternate solution here present. Here I can place one. So delete this two as it's not necessary here. Then and this beam is also not required at all. And after that, I hope this beam is also not required. So this is how we have created the school, each framework. Now what I have to do is I have to again save it, control save as S1, save it. Okay, now what I have to do is I have to now simply right click in this area and click on add or modify grids. Now I have to modify this, how many stories are being present here. Click in add or modify. So in the lowermost level you have to keep it as plinth level. Now go to the 3D view of the model, then plinth level. As you can see here, the plinth level is 750, so 0.75. After 750, the next level will be 3.6. okay, 3.6, then again 750 plus 2.85 will come as 3.6. so now height of the floor to floor will be 3.8. this one will, as you can see here, as I have kept as plinth level 1F and roof 3.6. so now place 7.95 total height, click OK. Now click OK. After that, go to plan and go to the plinth level and click OK. So these are the grids. Where are my all grids which I have already created? Okay, it got deleted because those grids were being created in the top level. So simply click Ctrl Z 2 to 3 times. So now these grids are coming. Now what you have to do is you have to simply click all the grids and press Ctrl R, that is for the replicate. Ctrl R and replicate the same thing in the all the stories and click apply. See, I have replicate all the to the full. As you can see here, you can now my base is also, it looks like. Now again go to the add modify grids, plinth level. This one is 1F, this is then this one is the roof, then delete this portion. This one is 0.75, this is 3.6, then again this is 3.6, total is 7.95. Okay. So this is what we have created. Now go to the 3D view. As you can see here in the 3D view, you can also even click this button to see the extruded view. So our building looks like in this manner, as you can see here. Now again go to the plan view. In the base level you have to go to the base level, then after going to the base level select all the joints After selecting all the joints, go to the assign joint, assign restraints. You have to click it in the fix support and click apply. Okay, now again go to the 3D view, and you can see here that all the supports are being changed from the pin support to the fix support. Now again go to the plinth level. After going to the plinth level, now what you have to do is, in the plinth level, as you can see in the architectural drawing, there is no presence of any kind of floor in the plinth level, so you don't have to create any floor in the plinth level. But in the first floor you have to create the floor, and whereas in the second floor, as you can see here, there is floor in the first floor, and there is the presence of one truss in the second, that is in the roof, not in the second floor, but that is in the roof. And also there is the presence of one mumty in the above the staircase in the first floor level. So again go to this building. So what I will do is, this is the 1F level. So in the 1F level everything will be present, but in the roof level what I will do is, in the roof level, as the staircase is present here, only in this portion the staircase is present. What I will do is, I will delete all, only I will keep the staircase as intact. I will keep only the staircase as intact, and I will delete everything. And let me even check here where the staircase is. This is the staircase, so I will not delete this one. This is the staircase, so I'll okay, let me delete this portion. So here the staircase is present here. This is the staircase present here, and this is the portion of the roof where the truss is being present. But remember that wherever the truss is being present, so there is no necessary of more number of beams, so you can remove this type of beams, or simply keep it whatever it's present. So now again go to the 3D view and check how it looks like. Click the extruded view, see, it doesn't, see, this is how it looks like. So this is the headroom of the mumty, and this is the another headroom of the mumty, and this is the portion where truss is being present. So now again go to the 1F level, and after going to the 1F level, go to again define. After going to the define, go to the section properties, then go to the slab sections, then here make a new property of slab. So what I will do is, I will simply go to this one and I will modify the properties as, from here I have to select as 0.25, and make it a slab, and thickness of the slab it as 125 mm. Okay, so let me delete this too. Do one thing, again go to, now what I will be doing is, I have to assign these slabs to the 1F level, that is, you have to simply go to this portion, then I have to click as slab. Let me check what is the name of the slab sections I have provided. Where is my slab section? I hope it's got deleted. Let me do one thing, add new property. So this is what is present. So this one I have created as, so this one I have created it. Okay, so this is the Mumty and this is the truss for the roof level. Then what I will do is I will go to the 1F level. After going to the 1F level, I will be assigning the slab, and for this let me go to the define slab sections, add a new property, slab 125 shell thin, modify as 0.25 0.25 0.25 0.25 0.25 0.25. okay, let's keep it as 125. Okay, delete these two things. After that clip it as okay. Now go to this slab portions as, now go to the slab, and as you can see here, this is the level 1F. so now I will be placing the slab. What I will do is I will simply okay. So now what I will do is I will delete those unnecessary, wherever it's present, and wherever it's required I will place there I have placed it. So as you can see here, now again go to the 3D view. As you can see here, again go to the roof level, and here place the roof wherever the Mumty is present. Now again go to the 3D view. See, as you can check here, this is how it looks like. Now again go to the plinth level. After that what you have to do is you have to now again go to the define, then go to the load patterns. Dead load is present, live load is present. Now again add another load, that is superimposed dead load, SIDL dead load. This is super dead, added. Then live load less than 3, live load, add it. Make this one as live load greater than 3, modify it. Okay, live load less than 3, greater than 3 I have added. Then add a new load, that is wind load earthquake X. You have to add the earthquake load X. Then go to seismic IS 1893 2016 will be present. 2000, this one is the 2002. We have to select 2016, add it. Then Y, add it. Then so this is what load patterns I have added. Now let me add some another load pattern, that is wind load X. Then wind load X, wind load, where is wind load? Yeah, wind load. Then 875 part 3, add it, wind load X. Then wind load Y, add it. Okay, another load we have to add, that is add another load. The name of that load is roof life. Add it. Now press OK. After that what we have to do is again go to the load pattern. Again go to the load pattern there, especially in the seismic and wind load. Go to the seismic load, go to modify. This is the seismic load X. So all X should be present, Y should be remove all the Y. then response reduction is 5. Importance figure, always remember that the importance factor, there will be 3 type of importance factor as per IS 1893/2016. For residential buildings you have to keep the importance factor as the 1. For other type of commercial buildings you have to keep as 1.2, and for the important buildings as such as school buildings as critical care hospitals and all this, for them we have to keep it as 1.5. remember that if the importance factor increases then our reinforcement will also increase, so this is one of the major point to keep in mind. And this is the zone factor as per zone 5. Our Assam is in zone 5, so zone so 0.36 will be there. Then we have to calculate the time period. For calculating this time period, let me use this one, user defined. So what will be the time period, how to calculate the time period, I will tell you. So for this click OK. So now again press Control M or go to view, measure. From here to here, what is the distance? 58.8. So this is the 58.8, and from here to here distance will be 32.25. 58.8 and 58.8 x and y is 32.25. and what is the h? The h is 7.95. This is 7.95. okay, so h is 7.95. so what will be the time period? So as per IS 1893 the time period will be, go to the load calculations, load cases, go to the load patterns, earthquake. This is for x, so time period will be, its formula is 0.09 into h, that is 7.95 divided by root d. So along the x the distance is 58.8, so it's coming as 0.09 into h divided by root over 58.8, it's coming as 0.093. okay, so now go to y, modify importance factor 1.5, user define 0.0, again 0.09 into h, 7.95 divided by root over 32.25, it's coming as 0.126. so okay, so for the wind load keep it as standard, terrain capacity 1, importance factor 1. This importance factor is different, this is for the wind load. And remember that wind load as per our Assam for the Guwahati city it's 50, so everything is okay. You don't have to incorporate for the wind load, keep it as okay. In those buildings wherever we have to change the wind load, I will tell you in details. So especially in this building, as this building is a very low height, not even 10 meter, so wind load effect will not be present here. So simply don't disturb the wind loads. So now the earthquake I have already edited it. Now go to again define, and then in the define sections remember that we have to do the dynamic analysis of the building as well as the static analysis of the building. So for that what you have to do is you have to go to the response spectrum. Here add as per IS 1893/2016, add new function, zone 5 0.36, importance factor as 1.5, soil factor soil type 2, response reduction factor 5. okay, everything is okay. So here write as response spectrum RSX, response spectrum RSX, or response spectrum, this is for, or simply write as response spectrum horizontal. okay, now add another function, now write as response spectrum vertical. So for the response spectrum vertical, whatever you have to do is you have to delete all this, what we have to do is for the zero, the value will be 0.0 Remember that this value is also present in IS 1893 2016. So if the importance factor is, remember that if the importance factor is 1, keep the value as 0.06. If the importance factor is 1.2, keep the value as 0.072, and if the importance factor is 1.5, keep the value as 0.09. that is 0.6 into 1.5 as 0.09. so our importance factor is 1.5, so we will keep the value as 0.09. so for 100 also, for 0 it's 0.09, and for 100 also 0.09. so you don't have to like look at every time the code book and you have to check. So simply by heart is that if the importance factor is 1, its value will be 0.06. if the importance factor is 1.5, it's 0.09, and its importance factor is 1.2, then its value will be 0.072. okay, fine. So now for horizontal and vertical we have done it. This one delete it. Okay, now again go to the functions, then response spectrum is done, then go to the mass source. Now go to the mass source, and in the mass source what I have to do is write as mass source, then remove this two. For the dead load the mass source will be 1, and for the win load, for the live load which is greater than 3 is 0.5, and for less than 3 is 0.25, and for RS SIDL is, so I'll merge everything. So I'm merging all this. So what I'm doing is I'm merging all this. Let me merge everything. Wherever beams are not present, there I have to merge it. I'll merge it. So now let me do one thing. Let me go to the ground floor. In the ground floor, that is in the plinth level, here the walls will be present. So let me select all those beams. See, this beam and these beams are not connected. So what we'll do is let me select these two beams, then go to join frame. Now it has been selected as 1. So in the similar manner what I will do is let me select, and I can check where the beams will be not present. Let me do one thing. Let me first go to all stories, select all, then join frames. Now again go to join frames. Now what I will do is I will be selecting all the beams. What I will do is I will be selecting all the beams, then click on join frames, then again I will select all the beams and click on divide frame, break at the intersection of the selected join. Okay, so now I will be selecting all the beams, only one story, and I will select all the beams. So this is how we have selected the periphery of the building, because here it's compulsory that the wall will be present. After selecting the periphery of the building, I will click on assign, then frame load assign, then the distributed load. What will be the SIDL, superimposed dead load? The load will be, how much the load will be? The load will be thickness of wall 150, so 0.15 into 3.6 height into 20, so it will come as 10.8. so click on OK. so this is how I have provided the load of the walls over the beams, over the plinth beams. Now let me again check if somewhere else the walls are present. As I can see here also the walls are present. See, this one wall, this one wall, and here also the wall is present. This is the wall. Then another wall is present here, it's present over here. So wall is present over here, then here it's present, then after that it's present here, then here, 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 then here, no, it's not present here. Here also the wall is present. Then click apply the load I have provided, but here it's not present. As you can see here the wall is not present. Now what I have to do is I have provided the walls. Now after everything is done, now let me go to the first floor, and in the first floor as you can see here there will be parapet over the wall, but here there will be presence of roof, truss, and here also the mumty will be, here also the mumty. So let me select this one wall. Let me divide it as, so let me select this wall, this wall. Let me select these walls, because here the mumty is present and here also the mumty is present. Mumty means, I hope it's clear to all of you that it's a type of headroom. So there 10.8 same mumty is present, and the remaining one is the slab. So this is the slab of staircase and this is the slab of staircase. So here we have to apply load of, here we have to apply the load of shell load of less greater than 4 for only for the staircases, and in the remaining others we have to apply the, instead of selecting in this manner, simply go to select, object type, slabs, floors, select, then unselect this two and also unselect the two which is present at the roof. Now these are all I have selected. Then assign the shell load of roof life, that is 1.5. okay, after that even roof life is present here, so here also assign it. By mistake I have forgotten to assign it. Here also the roof life of 1.5. then above these two there must be again roof life of 1.5. then after that in these walls there will be parapet. So what we will do is, in the boundary walls we will be selecting all the boundary walls, Here we will assign the frame load, assign frame load distributed superimpose dead load for the boundary. Suppose it's 0.15 multiply by 2.5 meter, the height of suppose it's 1.5 meter the height of parapet into 20, it's coming as 4.5. Okay, so at the top there will be truss load will be present. So let me select this one, divide, again divide. So let me select this. Yeah, the truss load will be present because there will be the presence of one truss. So select here, assign frame loads, and provide the superimposed dead load of the truss as 1.5. okay, so now it's done. As you can see here, all loads are being now provided. The load of the trusses present, the load of the slab is also, the self weight of the slab is present, the roof live is present, everything is done. But remember that slab must be present at the first floor, not at the bottom, because in the bottom of, that is in the plinth level or at the bottom, we will be simply doing PCC by providing the bricks. So here we will not apply the slab. After everything is done, now we will click on analyze, run analyze. But before going to click run analyze, we have to click on analyze, check model, select all. okay, if some errors will be present, then it will come automatically. See the model has warnings. What warning says? There is the presence of some overlapping columns which are present, so automatically there this will come. Let me analyze, check. Let me check this one. See, it's overlapping simply. Let me check here, analyze, check model. I will pause the video and I will remove all the errors. Check models. See, these are the columns where overlapping is present. See. In this two there is again, see, this is how I have removed all the errors. Now you can see, now no errors will be available. See, the model check, no errors and warnings. This is how. Always remember that after creating the models, don't forget to check for the errors. Now let me do one thing. Let me now go to the run analysis. Now let me run the analysis. So now the analysis is going on. See, as you can see here, the analysis is now being done. Now after doing the analysis, simply press Control T. This is for table. Go to the structure, base model, and base reactions and model participation mass ratio. So base reactions we have 2014 for static X and static Y. But if we will be going to check for the reactions, is there is no presence of response spectrum. So what we will do is we will unlock it. Now we will go to the assign, set load cases to run. Then what we will do is simply we will go to the load cases. Then after going to the load cases, here we have to provide three type of another load, because static earthquake is present X and Y, but response spectrum is not present. So we will provide response spectrum X, response spectrum U1 horizontal. Okay, response spectrum X. Then again add response spectrum Y, response spectrum Y, add it to horizontal, and again another one, add it response spectrum Z, response spectrum 3, this is vertical. Okay, after it's done, again click on analyze, because it's very important to do the analysis for both the static earthquake as well as dynamic earthquake. So now again press Ctrl T, then check base reactions are present 2014. Now check for the response spectrum, it's 1087. We have to scale it to the same. So for scaling up, what we will do is, so for scaling what we will do is 2014. So now we'll divide as 2014.5607 divided by 1087.58 1.85, done. Now what we'll do is we will go to the load cases. Here we will multiply as whatever the value we have got, we will write that. One 1.85233346 18 165. Okay, so 2014. Now let me check how much value, 2014, 2013. It's okay. So now let me, after doing the earthquake analysis, now for dynamic as well as static, now place on, go to design. This is the concrete design button. But before going to concrete design button, let me go here and check which IS code I have selected. Review and revise IS 456, everything is okay. So now okay, so again press it. So as you can see here, some memberses are being failed. Those red color memberses are failed. It means how to check? Simply go to this portion and verify all members passed. 25 concrete failed design, click OK. Yes. After that, right click and show selected members, show the selected objection. So these memberses are being failed. Only columns are failing, the beams are have been passed. So how they are being failing? Select it here, right click, then after the details, if we go to the reinforcement required axis maximum allowed, so we have to select the larger size of column. So for that, what we will do is simply show all, then unlock it, and after that what we will do is, instead of selecting members one by one, do one thing, go to select object type, select all the columns, select. After that, go to assign frame, instead of 350 by 350, provide us 350 by 450, apply it. Okay, now again do the analysis. After doing the analysis, now again we have to scale the base reactions, because now earlier it was 2014, it has now 2044. So it is these two are also changed. So you have to divide this by this as well as this by this, and you have to change the scale factor. But I will do that afterwards. Now let me go to directly to the design portion and check for the design. So now I can 100% assure you, see all the members are being passed. See, now let me go to this portion and check, verify all members. See, 12 members are failing. Then let me go to select and show the selected members only. Now also some members at the bottom portions are being failed. It means as you can see here, it's these members are also failing maximum allowed. Okay. So instead of this one, so now what we can do is, instead of providing, go to frames, so instead of providing 350 by 450, what we will do is, we have provided 350 by 450, we will provide it as 400 by 450. Now press OK. Now again go to the design check. So now only some of them members are being failed. So in this manner we can do the analysis. After that, simply press shift control and F6. After going pressing control shift and F6, this menu will come. Then we will check for the total rebar percentage, click apply, then we will go to the elevation and click OK. As you can see here, what is the reinforcement which are present in the columns: 2.2, 1.80, 1.26. so it's very the reinforcement is less than 2.5%, so it's very practical. As you can see here, all the reinforcements are coming very practical. Okay. So but in this column says it's coming high. The reason is because here in both the sides the size of the beams are very large, around 7.9 meters, 7.9 meters. So what we have to do is, in order to reduce the reinforcement in this column, we have to increase the size of these two beams. So in this manner we can do the designing. So after doing the design, what we have to do is we have to simply go to this file portion and we have to click it, but before that what we will do is in the last step we have to press Ctrl T, and again we have to scale up the base reaction 2064 Then let me scale up the base reactions and for static and as well as earthquake, static earthquake as well as dynamic earthquake. Define load cases. This value is higher out of RSX and RSY. The value which is higher, we will place that higher value in RSZ. Okay, unlock it, and again do the analysis. After doing the analysis, we will check for the base reactions. We have to now Control T, check the base reactions, say it's 2064 now. Okay, now go to file. Now go to, after going to the file we have to go to export. Then we have to go, after going to the export we have to go to the Etabs file data to SS. Remember that we have to do Etabs database table to SS. The reason is we have to convert this to the SS file. After converting this to the SS file, we have to create, we have to extract, not create, we have to extract all the datas like how much reinforcement, what are the reinforcements which will be provided in the beams, columns and everything. We have to extract by using the RCDC software. So for that what is required is Etabs database table to SS. Select, only select those which I have mentioned here. Okay,